Hey guys, good morning, afternoon, or evening. Today we're going to be looking to still with the power rule for integrals, and we're going to look at the integral symbol now rather than calling it the antiderivative. We're going to now call it an integral, and we're going to write this in a better way so that it's easier to understand. So the first thing that we'll do is we'll define the integral symbol here for you. So let me just change to marker here. Okay, so if we have this is our integral symbol. And we're going to write the derivative as so if we have, say, y equals, let's say we have y prime equals, let's say, 6x squared minus 8x. Find y. Now we are going to write y prime using the fractional symbol because it helps with integrals in our second part here. So if we say that this is dy derivative of y with respect to x, like this, we write it like that. And then if we write that as equal to this, we can do an integral now. If we want to go back to y, how we write it using the integral symbol, this tells us to go back to y. We can write it like this. We can say that dy equals this whole thing times dx. So we're just multiplying the dx in the bottom. So this is it. Now, if we want to go back to y, we can integral this and we can integral this. So let's do it up here. So if I take the integral of dy, it's y, and that's going to equal the integral of 6x squared minus 8 dx. So this is how we will write integrals from now on. We'll use the fractional form here, and then we'll split it into two pieces by multiplying the bottom out. So if I were to integrate this now, I could use the power rule. So just using the power rule, remember what the power rule is we just add 1 to the power here, and then the same number underneath it. Okay, so if I use the power rule, this would turn into y, and this would turn into 6x 2 plus 1 over 3 minus 8x over 1, and the dx is gone because we've integrated back plus the constant. So if we work that out, y would then equal 2x cubed minus 8x. Okay, plus or c. Okay, using power rules. Okay, so that's the integral symbol. So that's how we're going to write it. We call this an indefinite integral. Okay, because when we use this symbol, we'll have definite integrals come up later where there's numbers involved, but right now we just call this an indefinite integral, and this using this integral symbol. So let's do a couple examples of some indefinite integrals and see how they work. So the first example that I'm going to show you, okay, is one where you're going to use expansion and then integrate. Okay, so let me just get my timer out here. This will be a short day as the practice work is going to be included in this day. So I'm going to try to keep it in that 25-minute range, and then you can do some practice integrals. Okay, so let's do an expansion example here. So let me get one out of my practice sheet here. Okay, straight integration examples. Let's do an expansion one, and then we'll have to do a rewrite one as well. Let's do an expansion one first. So let's say that I have dy dx is equal to, let's say, let's go with something like 2x squared minus x times 4x minus x squared. Okay. So that means if we're going to, and it's going to say find y. Okay. So if we were to write this in integral form first, so we split this up, dy equals 2x squared minus x times 4x minus x squared dx. So we're going to expand this part out. So 6x cubed minus 2x to the fourth minus 4x squared plus x cubed. So 6x, so again, we're just multiplying out, sorry, that's 8, not 6. 2 times 4 is 8. Oopsie. All right, so 8x cubed, and then 4 minus 4x to the 4, or 2x to the fourth, and then this one here minus 4x squared, and then plus x cubed. So we can combine this, and that's the whole thing times dx. So we've expanded it out, so we can combine the cubes, and let's do it in ascending order. So dy is equal to, starting with negative 2x to the fourth, okay, and then add these two together, plus 9x cubed, minus 4x squared dx. Okay, and then we can integrate it. Put our integer symbols in there, and then we can use our power rule here. So this would be 9 minus 2x. Okay, we got to add one there, so 5 over 5 plus 9x to the fourth over 4 minus 4x to the third over 3, and that's plus c at the end. Okay, and can we reduce anything? No, that's as far as we can reduce. Okay, so that's an example where we have to do expansion. Okay, sometimes you have to do expansion that has a division as well. So we'll do that one on the next page, as I used up pretty much there. Okay, so that's the first example. Second example, say example 2, where we have to do some simplification, we'll say. Before integration. Okay, so let's say something like this. Let's go dy dx, the derivative turns out to be equal to, let's say, 8x to the fourth minus 12x squared plus 4x all over 4x, something like this, dx, or oops, we don't have dx. I was getting ahead of myself there. Okay, find y. Okay, so in this case, these are all dividable, so that we'll divide out the 4x. So we can write this as dy equals, now I'm going to divide this out at the same time. 8 divided by 4 is 2. X to the fourth divided by x to the 1 is x cubed. Minus 3x plus 1, bracket, bracket, dx. Okay, so we do the simplification before we integrate in this case. Okay, so which makes it easier to use the power rule again. So basically we're trying to do the power rule here. Okay, so let's go ahead and use integration rules. So put our integration symbol in. Okay, so y equals, okay, this one first, 2x, add 1 to that and divide by it, minus 3, add 1 there, power, and then divide by it. And then, of course, here, add an x, and then, of course, add the c. Okay, does anything reduce? Nope. So there is our y value for that particular question. So there's an example of where you might have to do a dividing simplification. Okay, there is a third type that comes up where you have to do some rewriting or rearranging, and that's maybe when you get roots in the symbol and you have to redo the roots and stuff. So our third example that I'll show you is with root powers. Roots converted to powers. Okay, so let's say if you had an example with some square roots in it, and let's even have multiplication in there, where let's make it a little bit more complex. Let's say dy dx turned out to be equal to 3 minus x squared root x. Something like that, okay? Okay, so we would have to write it into this form here. Move that dx over like that. Okay, now before we could use the power rule here for antiderivative or integration in this case, is we have to convert this into exponential forms. Okay, so nothing happens with the 3. It stays the same. Okay, and our first step here is we're just going to say this is x squared times root x, which would be x to the 1/2. Then we have dx. Okay, so now we know that exponential rules, when you have the same base, you add the power, you add the exponents. So that we're going to end up getting 3, and then we got to go 2 plus 1/2. So 2 plus 1/2, well, it's best to write that as a fractional form, okay? So this is going to end up being minus x 5 over 2. This is, if we take it over halves, it's 4 over 2 is equal to 2. So 4 over 2 plus 1/2 is 5 over 2. Okay, now we can use the rule because we have this one and this one just with powers. So now we can just integrate it. Stick our integration signs in there. Okay, and we've got y equals. Okay, so 3x. Okay, now we got to be careful with this one because it's fraction. So we got to add 1 to it. Okay, so x, adding 1 to 5 over 2. So 1 is 2 over 2. If we add 2 over 2 to that, it's 7 over 2. And then we have to divide by 7 over 2. And we have to add c. Okay, now we can do some simplification here. This would be like, since we're dividing there, we invert and multiply. So this would give us y equals 3x. Okay, and then we go minus, and then 2x to the 7 over 2, 7. Okay, plus our c. Okay, we could leave it like that if we wanted to turn this back into a root. This would be, if we did that as a root, that would be square root of x to the 7th. Right? So you can write it like, put that there instead if you want, but both are correct. Okay, so there's the 3 examples. Here's an example of rewriting it, simplifying it first. Here's a rewriting it into powers. And then the very first one we did was just where you have to expand it. Otherwise, if you just get the statement, you just have to do regular integration as well. So you could have an example of regular integration just with a statement and then using the power rule in there. Okay. What could there be combinations where you have to maybe convert it and expand? Yes. Okay. So those are the basic 3 types. Okay. Mostly today, I'm going to get you to do some work. Let me just take a look at. Maybe we'll do one more example here. Let me just take a look at what the practice looks like here and see if there's anything missing there. Oh, negative exponents. Yes, negative exponents. So let's do one more with negative exponents. Almost forgot. So example 4, what if you have expressions, I guess would be the best word, with negative powers. Okay, so let's say something that looks like, let's see if I got one here. Okay, let's say we have this one here, like, let's do, where did I see that one? There's my example. Okay, so let's say we had dy dx equals, let's say it is 7 over x minus 5 over x squared. Okay, so it's written like that. So we have to, so this is dy equals 7 over x minus 5 over x squared dx. So we rewrite this using negative exponent rules. So this is dy equals 7x to the negative 1 minus 5x to the negative 2, of course, dx. Okay, so we can integral here, or integrate. It's not the best integrate symbol, but so be it. So we're going to go 7x. Okay, we're going to add 1 to that, to the 0. X is 0, remember, is 1. So don't get thrown off there. And 5x to the negative, divided by 1, because that's what that would be. Okay, and then this one here, if we add 1, we get negative 1, and we're dividing by negative 1, plus c. So this would be y equals 7 plus, because this is 5x to the negative 1 plus c. Don't forget your c. Okay, so there's an example where you have some negative exponents. Could you have a combination of two things? Sometimes you do. Let's do one more here, and then I'll give you an example of. And then I'll give you the practice to do. Okay, so let's say we have powers with a root on the bottom. So let's say we had something like dy, I'm going to write it like this already, equals, let's say I had x cubed plus 2x minus 4 over root x dx. Okay, so just to mess everybody up. Okay, so we have to convert this first. Okay, so if we're going to convert this, we don't need an equal there. Actually, I should d at y equals, yeah. Okay, so let's say that I have to convert this. So this is 1/2. So we have to think of this as x to the 1/2. And when you're dividing, you have to subtract. So this would be x to the 3 minus 1/2 is 2.5 or 2/2, which would be 5 over 2. Plus 2, 1 minus 1/2 is x to the 1/2. And this one's tricky. We have, this would be just a negative powered one. So this would be negative 4x to the negative 1/2. You're just bringing it up. Okay? And then you could use your power rule to integrate that now. So if we were to integrate that, y would equal, okay? So this would be x to the 7/2 over 7/2 plus 2x to the 3/2 over 3/2 minus 4x to the 1/2 over 1/2 plus c. Okay, we can do some reducing on each of these. So y would then equal, okay, 2x to the 7/2 over 7. Okay, this one will be flipped over, so it'll be plus 4x to the 3/2 over 3. And this will be flipped over again, minus 8x to the 1/2 plus c. Okay, so there's our examples, and that should get you through all of the examples that you would have. That's about 24 minutes. So I want to stop there with examples. Okay, and I'm not going to get you to do all 21 of these. I did some examples from the first column here. So do the even column here. Okay, you can see there's some simple ones. There's one with a cube root on the bottom. There's one with a square root on the bottom. Here's an expansion one. Here is negative powers. Here's one that you have to convert. Here's another one you have to convert. Okay, so if you work on the even examples here in the integration assignment, and sorry about this being upside down when I scanned it, but you can print it out. Maybe I'll have to fix that. But you can work on that for the other part of the period here today. So work on the even ones here. Should be good enough. You get those. If you want to do more, that's up to you. But do at least those. So good luck with that. And then tomorrow we're going to get into some more complex integration stuff when we start using something called the substitution rule. All right, so good luck with that.